Hello viewers, in today's class we are going to discuss one important concept in three-dimensional geometry, right? So here we are going to discuss the concept of intersection of two planes and the equation of the plane passing through the line of intersection of the given two planes, right? So let us start. Now here we are given a problem. Find the equation of the plane passing through the line of intersection of the planes. So here we are given the equations of two planes, and the plane passes through the point 4 comma minus 3 5, right? So let us first analyze this problem, and then we'll try to solve it. So here actually we are given the equations of two planes, right? So let us denote the planes by P1 and P2, right? So the first plane is 2x plus 4y minus 3z plus 5 is equal to 0, and the second plane is 3x plus 5y minus 2z minus 1 is equal to 0, right? So viewers, let us draw this plane P1. So here we will draw a rough sketch of the problem. So here we have the plane P1. We can take it as plane P1, and the plane P2, it can be drawn like this, right? So this is the plane P2, right? And these two planes, right, we have to find the equation of a plane which passes through the line of intersection of the planes P1 and P2, right? So here this line, right, see these two planes P1 and P2 intersect at this line, right? So this is the line, and these two planes P1 and P2 intersects at this line, right? So now we have to find the equation of a third plane which passes through the line of intersection of these two planes P1 and P2, right? So this line is called the line of intersection, right? So this is the line of intersection of these two planes P1 and P2. And always remember that whenever two planes intersect, they intersect in a line, right? But when two lines intersect, they intersect at a point, right? So we have the intersection of two lines. So whenever two lines intersect, the lines intersect in a point. But when two planes intersect, they intersect always in a line, right? So now we have to find the equation of the third plane which passes through the line of intersection of the two given planes P1 and P2. So we can draw the third plane like this, right? So we have to find the equation of this plane P, right? Okay, so now we know that whenever two planes intersect, right, then the equation of the third plane which passes through the line of intersection of P1 and P2 is given by P1 plus lambda P2 is equal to 0, right? So this equation gives the family of planes which passes through the line of intersection of two planes P1 and P2, right? Where lambda is some scalar, and for particular value of lambda we'll get a particular plane, right? So we can impose different conditions, and corresponding to the given condition we can have the value of lambda, right? So P1 plus lambda P2 equal to 0 is the equation of the family of planes which passes through the line of intersection of the planes P1 and P2, right? So here we have to find the equation of the third plane P for some value of lambda, right? So here we are given the problem that find the equation of the plane passing through the line of intersection of the planes. These two planes are given, and the point 4 comma minus 3 comma 5, right? So it means that this third plane P, it passes through some point 4 comma minus 3 comma 5, right? So this plane P, whose equation is to be calculated or required, it passes through the point 4 minus 3 and 5, right? So this point will be utilized to find out the value of this scalar lambda, right? So now viewers, here we can substitute the value of the equations of P1 and P2 in this equation. So for P1 we have 2x plus 4y minus 3z plus 5, and for P2 we have 3x plus 5y minus 2z minus 1 is equal to 0, right? So this equation represents the equation of this plane P, right? So the equation of the plane P, which passes through the line of intersection of P1 and P2, is given by this equation, and once we get the value of lambda, we can find the equation of this plane P, right? So now this equation or this plane passes through this point, that is 4 minus 3 and 5. So therefore this point must satisfy this equation, right? So we can take x is equal to 4, y is equal to minus 3, and z is equal to 5, and we can substitute these values in this equation. So we have here 2 times 4, then we have 4 times minus 3, then we have here 5, then plus 5, and then lambda, and here we have 3 times 4, then we have 5 times minus 3, and then we have minus 2 times 5, and here we have minus 1, that is equal to 0, right? So now this is 8, this is 4 times minus 3 is minus 12, here we have minus 15, then we have 5, and here we have lambda, this is 12, 3 times 4, this is minus 15, and this is minus 10, minus 1 is equal to 0, right? So now we can simplify it. So this is 8 minus 12 is minus 4, and minus 15 is minus 19, plus 5 here, and then we have lambda, here we have 12, and this is 25 minus 26, right? So now this is 5 minus 19 is minus 14, and here we have lambda times we have here minus 14, right? So now we have an equation in lambda. So we have minus 14 lambda is equal to 0. So minus 14 is equal to 14 lambda. So lambda is minus 14 over 14, that is minus 1, right? So we have obtained the value of lambda as minus 1, right? So now we can substitute this value of lambda in equation 1 to get the equation of this plane P. So viewers, here if we take lambda is equal to minus 1, we have 2x plus 4y minus 3z plus 5, and here we have minus 1, this is 3x plus 5y minus 2z minus 1 is equal to 0. So this is 2x plus 4y minus 3z plus 5, and multiplying these 4 terms with negative 1, we have minus 3x minus 5y plus 2z, and here we have plus 1 is equal to 0. So 2x minus 3x is minus x, 4y minus 5y is minus y, minus 3z plus 2z is minus z, and 5 plus 1 is 6, right? And now multiplying both sides by minus 1, so we have this equation as x plus y plus z minus 6 is equal to 0, right? So viewers, the Cartesian equation of this plane P, which passes through the intersection of this plane P1 and P2, is given by x plus y plus z minus 6 is equal to 0, right? So this is the Cartesian form, and if we wish to write it in vector form, then we can write it as vector r dot I cap plus j cap plus k cap minus 6 is equal to 0, right? So this is the vector form of the equation of this plane P. And from this equation we can easily verify that this equation satisfies this point, right? That is 4 minus 3 5. That is, if we take 4 minus 3 5 over here, we'll get 4 minus 3 plus 5 and minus 6. So we have 4 minus 3 1 plus 5 6, 6 minus 6 0, right? So this point satisfies this equation as well, right? So viewers, this is how we solve this problem.